All right, let's talk about NASA's Artemis program. Now, if you're picturing a simple rerun of those old, grainy videos from the 60s, you've got to rethink that. This is a completely new chapter in how we explore space. And trust me, it's about way more than just planting another flag.
Okay, so let's just get right into it because it's the question on everyone's mind. Going back to the moon, again, we've been there, done that, right? Why on earth are we spending all this money to go back? Well, the thing is, the reason we're going this time is fundamentally completely different. The why has totally changed.
And this slide just nails it. Apollo, you see, was a sprint. It was all about the Cold War, a race against the Soviets to prove who was top dog. The missions were short, in and out trips. Artemis, on the other hand, is a marathon. The whole point is to create a sustainable, long-term human presence on the moon, with our eyes on an even bigger prize down the road, Mars. So, if this is a marathon, what's powering it? Let's get into the hardware, starting with the absolutely incredible machines that get us off this planet in the first place. Okay, so let's look at the heavyweights here. On the left, you've got the new kid on the block, the Space Launch System, or SLS. And on the right, the absolute legend, the Saturn V. Now, the Saturn V was actually a bit taller, but the SLS, well, it packs a much bigger punch right at liftoff. But here's what's really interesting. In its current version, the SLS actually carries less to the moon than the old Saturn V could. That's going to change with future upgrades, but man, it just shows you what a beast of engineering the Saturn V really was. This chart really helps you feel that raw power. That SLS bar is about 15% higher than the Saturn V. And get this, a massive 75% of that initial power comes from those two solid rocket boosters. You know, the white tubes dropped to the sides. They're basically supercharged versions of the same boosters that were used on the space shuttle. Just let that number sink in for a second. 8.8 million pounds of thrust. That is just incredible. It officially makes the SLS the most powerful rocket operating in the world today. It's the engine you need for a program this ambitious. Okay, so getting there is one thing, right? That's only half the battle. Artemis is completely rewriting the rules for how astronauts will actually live and work in deep space. We're moving away from a quick camping trip and towards setting up a permanent outpost. And just look at this comparison. It's a night and day upgrade for the crew. The new Orion capsule is way bigger than the old Apollo command module, but the real game changers are endurance and safety. Orion uses solar panels, so it can operate for weeks on end, not just a few days. And maybe most importantly, it has an atmosphere like we have here on Earth, a mix of nitrogen and oxygen, which massively reduces the fire risk that was a constant danger in Apollo's pure oxygen capsule. Now, this is where things get really clever. It's not just how we get there, it's where we go when we arrive. Artemis isn't using the simple low lunar orbit that Apollo did. Instead, they're using this thing called a near-rectilinear halo orbit. It's this incredibly stable, super fuel-efficient orbit that's basically a sweet spot for a new space station, the Lunar Gateway. So this new orbit makes a whole new kind of mission possible. Here's how it works. Orion flies to the moon, and instead of going straight down, it docks with the Gateway. You can think of the Gateway like a permanent base camp in orbit. From there, the astronauts hop into a dedicated lander for the trip down to the surface. It's a total game changer for doing this long term. And speaking of the surface, Artemis isn't just a nostalgia tour of the old Apollo landing sites. Nope. We're headed for a completely new part of the moon, and for some really, really good reasons. So what's the big deal? Why the lunar South Pole? I mean, of all the places on the moon, why there? What makes this cold, dark place suddenly the most valuable real estate off-world? Well, it really boils down to three huge things. First, and this is the big one, water ice. In these craters that are permanently hidden from the sun, there are massive deposits of frozen water. This is a potential game changer. You can drink it, you can get breathable air from it, and you can even split it into hydrogen and oxygen to make rocket fuel. It's like finding oil. Second, it's a scientific gold mine. And finally, it's just a great place to set up shop. You've got spots with near constant sunlight for solar power right next to these super cold craters. You know, it's not just the technology that's different this time around. The entire team has changed. The whole idea of a space race, well, it's over. The future isn't about one country getting there first. It's about partnership, both globally and with private companies. And the Lunar Gateway is the perfect poster child for this new approach. I mean, look at this. It's not just a NASA project. You've got the European Space Agency, Japan Space Agency, and the Canadian Space Agency all building critical parts, like the next-gen Canadarm3. It's a truly global effort. And this right here is a massive economic shift. Back in the Apollo days, NASA did everything. They designed it, they built it, they owned it, the whole shebang. But now, for Artemis, NASA is essentially buying a taxi service to the lunar surface. They've put out contracts to private companies like SpaceX and Blue Origin to handle the landing. It's all about kickstarting a whole new lunar economy. So, when you start putting all these different pieces together, the brand new rocket, the deep space outpost, the commercial partners, the international allies, you start to see that this isn't just a series of random missions. There's a real, long-term plan taking shape. And you can see that step-by-step plan laid out right here. It all kicked off with Artemis 1, that uncrewed test flight back in 2022. Next up is Artemis 2, which will be the first time astronauts fly on this hardware. Then comes the big one, the historic landing with Artemis 3. And after that, you can see each mission builds on the last, adding new pieces to the gateway and expanding what we can do on the surface. And really, this quote just says it all perfectly. Every single piece, the rocket, the capsule, the orbit, the team, it's all part of a bigger strategy. This isn't just about going back. It's about building the roads, the gas stations, the entire infrastructure that will allow humanity to truly become a multi-planetary species. Which leaves us with one last big question. With everything we're building, with everything we're learning on the moon, how to live off-world, use local resources, operate for months at a time, is our closest neighbor really the final goal? Or is all of this just the ultimate dress rehearsal for that next giant leap?